Hi, welcome to my channel. My name is Sven and I hope you're doing great. Let's get started with today's episode on out of gamut colors. So first of all, we have to understand what a gamut is. You might have heard the term before, and oftentimes it's also called color space, which technically is a combination of a gamut and a transfer curve. A gamut is basically a collection of colors defined by three coordinates, one for each channel, red, green and blue. You can think of gamuts like maps. Different maps show the same streets and buildings, but one map might be detailed to only the western part of a city, while another map shows the entire city, and a third map shows the full continent. The scale of each map is different, and also maybe one map takes into consideration the curvature of the Earth, while another map does not. And gamuts are kind of similar. Most of them cover at least the lowest common denominator, and that would be the standard display color space Rec. 709 or sRGB. But still, each gamut has its own scale and orientation to cover different colors at the edges. S-Gamut 3, for example, is almost the same size as Airy White Gamut 4, and Red White Gamut is way bigger. In order to read this map, we have to roughly understand the CIE chromaticity diagram. Usually, colors should be represented in a 3D environment, since we have three dimensions for them, red, green and blue. And this scope simply shows us all the colors from a top-down view. This way we can see red on the right side, green on the top left and blue on the bottom left side. There's also this horseshoe-shaped curve called the spectral locus. This line represents all the pure color frequencies. And that's why you sometimes find numbers along it ranging from about 450 to 700. In simple terms, the inside of the shape contains all the colors that are visible to the human eye. And that's why all of the gamuts that are related to this place, like Rec. 709, P3 and Rec. 2020, are inside of this shape. Because displays can only reproduce a fraction of what the human eye can actually see, so they cover smaller areas within this shape. So now that we understand what colors inside of a gamut are, let's talk about colors outside of a gamut. If we go back to the analogy of maps, you could think of it like this. On a map that shows only the western part of a city, a building is located at, for example, 0.3 and 0.7. But on the map that shows the eastern part, this particular building is not visible. From a third map that shows the entire city, we know the exact location, so we could still give it a coordinate like minus 0.2 and 0.7 in the eastern map to indicate that we technically know where it is, but tell that it's outside of the map. And this is basically the same thing that happens with colors that are outside of a gamut. One or more of the color channels contain a negative value. But how is that possible? When cameras record light, they of course only record positive values since there is no negative light. But because in the digital intermediate workflow we apply color conversions from one gamut to another, it is possible that the math outputs negative values. And this is partly because the coordinates of those gamuts are different, but also because of the transfer curves of each color space. And I won't go into detail in this video, but if you want a fully detailed video about this, please let me know in the comments below. So in simple terms, each color space has its own transfer curve, for example log-C or ACES CCT. And when you do color space conversions, those transfer curves are able to drastically affect certain colors. And those colors are usually edge case colors, meaning they are highly saturated and contain very high values in the linear realm. But after applying the transfer curve, they move into the negatives. And that's why you will usually find out of gamut colors, for example in ACES, in neon highlights or artificial light. Common scenarios would be live concerts, emergency lights, neon signs and car lights, but we will see those in a minute. The first problem we see with those colors is the obvious: they look bad. It looks unnatural when a light source is super colorful but dark. We would expect it to be bright and maybe even lose a bit of saturation. But even when we don't notice them as aesthetically unpleasing, they still contain technical problems that can influence the grading process. So for example, while reducing saturation, the image can easily break apart if there's out of gamut colors. This happens because a saturation algorithm increases or decreases the difference between the three color channels. Decreasing it means the three channels move closer together. If one channel is far in the negatives, this means that the other two have to move down a lot as well, resulting in darkening the image drastically. Another problem occurs when you want to select certain colors with a qualifier. The qualifier works in the HSL color model, so it calculates the luminance of the colors in the third channel. And this calculation again is hugely influenced by the negative value in one of the channels, and therefore it creates a way too dark value in the luminance channel. So as we can see, keying becomes a mess. It can also happen that certain tools apply clamping. This results in cutting away information that could have been preserved. And this usually also simply just looks bad. With some tools, out-of-gamut colors can even create visible artifacts like white pixels or pixel clusters. And finally, also the curves behave kinda weird. For the hue versus curves, this is mainly true because they also work in HSL, so it's the same issue as with the qualifier. The color conversion to HSL creates the wrong values in the saturation and luminance channels. So, as we can see, colors that are out of gamut usually come with a bunch of problems, and it is our job as colorists to fix them. The most effective way is to fix them as soon as they appear, so we have to find out where that is. As we saw earlier, they usually exist because of color space conversions. So, for example in ACES, this would be the case right after the IDT, the input device transform that converts from the camera's input color space to the timeline working color space, in this case ACES CCT. And by the way, if you don't know what all of those terms mean, please watch my video about color management linked above and in the video description. We saw that out of gamut means one or more channels has a negative value, so does it help to lift this channel up? Well, usually those values are so far in the negative that a simple lift operation is not good enough. But ACES actually finally added a fix for this in ACES 1.3 that is called gamut compression. It is a tool that smoothly pushes back those negative values into the 0 to infinity range. But you can also use this tool even if you don't use ACES as your color management system. You just need to select the right input and output color space inside the ACES Transform OFX. And if you can't find a color space here, for example davinci Intermediate, just add a CST before and after that converts to ACES AP0 linear and back again. The cool thing about this plugin is that it comes with a bunch of sliders, so you can tweak the tool just the way you want to get rid of problematic colors without affecting the look of the show too much. So when we use ACES as our project color management, we can tick this box to apply the gamut compression with predefined values that work with most footage. And if we want to disable it for individual clips, we can then turn it off via this menu. But I personally usually do it a bit differently. The first node in my node tree is usually reserved for manual gamut compression. In this way I can tweak the settings for each clip. And by the way, oftentimes in the look stage when you use multiple very different tools that do some extreme things, it is a good idea to apply gamut compression every once in a while. We saw earlier that out of gamut colors usually occur right after the IDT, but that doesn't mean they can't appear later as well. I usually have at least one or two instances of gamut compression in my look stack, depending on what I do, just to be safe. So I hope you now understand what out of gamut colors are, how to spot them and also how to fix them. Let me know if you have any more questions about the topic and also if you want to see a highly detailed video about color spaces and transfer curves. Really like to hear your thoughts about this. So if you want to help out the channel, please hit like and subscribe if you're new here, and yeah, until then, I'll see you in the next video.